Hello, welcome to the fourth lesson of our first unit. This is special cases with systems of linear equations. Okay, we're going to get right into solving this linear system in all three different ways. So we have substitution, elimination, and graphing. And we're going to look at some special cases here. So first one, solved by substitution. So again, in order to solve for substitution, one of our variables needs to be isolated. This top equation already has one singular y, so we're going to isolate the y in this top one, and we do that by subtracting 2x from the left, so we get y equals negative 2x minus 6. Okay, now we're going to substitute that into the y of our other equation. So we have 4x plus 2 times negative 2x minus 6 equals 4. We are going to distribute to get 4x minus 4x minus 12 equals 4. When we collect like terms, we have the 4x minus 4x, which leaves us with 0 x's. Let's finish it off by adding 12 to the other side. But 16 divided by 0, there are 0 x's, so this does not exist. Okay, you can't find the y because it's not saying that x is 0, it's saying there are no x's. Okay. Can't divide by 0. Okay, if we have the same system through elimination, so we can multiply the top row by 2 because neither the x's nor our y's have the same coefficient. But let's multiply this top row by 2. So that it will match. So we have 4x plus 2y equals negative 12. And on the bottom we have 4x plus 2y equals 4. It doesn't matter which variable you choose, they both have the same coefficient. Let's just choose to subtract the x's. 4 minus 4 is 0. But then we get to the y's. 2 minus 2 is also 0. Again, cannot divide by 0, so this doesn't exist. What about graphing? So for graphing, we need them both in y equals mx plus b. You can work with intercepts if you want, but we can't always do that. So let's practice y equals mx plus b. Well, we know this top one. We have already done it, so you just move the 2x over. So the green one, we are going to start at negative 6. It has a slope of negative 2. We can't go down 2 to the right, but we can go up 2 and to the left 1. Okay, so that's what the line looks like. And then the second one, we're going to move the 4x over, so we get 2y equals negative 4x plus 4, and divide everything by 2, negative 2x plus 2. So if we graph this, plus 2, again the slope of negative 2. Okay, so substitution, elimination, or graphing, we never find a point of intersection with these because they are parallel. Okay, and a reminder of how we know that they're parallel, well, when we're looking at the two equations here, the identical slopes mean parallel. Okay, same slope. Means parallel. Therefore, no points of intersection. Okay, let's try with a different system. X plus 2y equals 2, 2x plus 4y equals 4. We're going to use substitution. This top one already has a singular x. Let's isolate the x here by subtracting 2y. So x equals negative 2y plus 2. And we're going to substitute this into the x down here. So we get 2 multiplied by negative 2y plus 2 plus 4y equals 4. Okay, distribution, negative 4y plus 4 plus 4y equals 4. And oops, sorry, that should be a 4y. Okay, collecting like terms, again, we end up with 0y, but this time, before, I'm just going to scroll back up, we ended up with 0x equals 16, a whole number. This time, if we were to continue on, even though we know that there's 0 y's, we subtract 4 from both sides, we get 0y equals 0. Okay, it's a little bit different. Let's continue on, and hopefully we can see the special case. Okay, elimination, again, the bottom row is double the top row. So let's multiply this whole top row by 2. And we end up with 2x plus 4y equals 4. And 2x plus 4y equals 4. So when we subtract these out, let's isolate the y's this time. But 2x minus 2x is 0. 4 minus 4 is 0. Again, we end up with 0x equals 0. If we look back at our other elimination, we had 0y equals negative 16. So when the lines were parallel, yes, we were getting 0x and 0y, but we are getting an answer still. Now we're having 0x and 0y, but the answer is 0. So what does it look like when we graph? Oh, I'm sorry. Okay, let's isolate y. So we'll get 2y equals negative x plus 2. Divide everything by 2. Y equals negative 1/2 x plus 1. The second one, we move the 2x over. We get 4y equals negative 2x plus 4. Divide everything by 4, and we get y equals negative 1/2 x plus 1. Okay, so you don't even have to graph it. We will, but you can see that this equation and this equation are the exact same. Okay, they have the same slope, but they also have the same y-intercept. Before we had the same slope, making it parallel, but they had different y-intercepts. Now, both of these lines are going to be the exact same. Sorry. I'm not very good at drawing lines this morning. Okay, and then the blue one would be the exact same points. Okay, so both lines are exactly the same. Therefore, there are infinite answers, solutions, let's say. Okay, when parallel lines, there were no points of intersection, no solutions. Now, these are the exact same lines, so it's infinitely the same. Okay, so the summary, there is no solution when the lines are parallel. An example, y equals 3x plus 4 and y equals 3x minus 7. Say, okay, same slope. There is one unique solution when the lines have different slopes. Okay, they can have the same y-intercept, but they have different slopes. There's going to be a point of intersection. So y equals 3x plus 4, y equals negative 5x plus 9. And there are infinite solutions when the lines are identical. Okay, an example of this, I'm not going to put in y equals mx plus b. Let's say 2x plus 4y equals 10 and 4x plus 8y equals 20. Okay, those are the exact same, they're just doubled. Also, when you're writing that there's infinite solutions, you don't have to write the word infinite. You could just do the sign if you want.